to Science Fantastic with Professor Michio Kaku. Today we're going to do part two of a great interview we have with an astronomer at Arizona State University, Professor Eric Aspog, author of a book with a rather outrageous title, When the Earth Had Two Moons. Not just one moon, but two moons. So today on Science Fantastic, we're going to talk about catastrophes. We're going to talk about collisions in outer space. You know, when you look at the universe at night, you think how calm and serene and how static and peaceful things are. But you have to realize that the moon was literally blown out of the planet Earth. Asteroids keep hitting the planet Earth, creating huge gouge marks and craters, changing the course of planetary life. Then we realize that the universe is a dynamic thing. It's not static at all. There are all sorts of cosmic catastrophes happening on a scale, of course, of millions to even billions of years. We have with us Professor Eric Aspog, Professor of Planetary Science at Arizona State University, author of the book, When the Earth Had Two Moons. So we're going to talk about catastrophes, cosmic disasters right here in our solar system. So Eric, once again, thank you so much for being part of Science Fantastic.
Oh, great pleasure.
Here's a question for you. Last time you were on, you talked about the fact that an object, maybe about the size of Mars, plowed into the planet Earth a little over 4 billion years ago, and that created the moon. Now, when I heard this theory, I said to myself, now, wait a minute. The Earth is round. Once upon a time, there was this huge gouge that was taken right out of the Earth because of this collision, but there should be remnants. It should be obvious where on the surface of the Earth this impact took place. So what are your thoughts? Do we have any notion as to exactly where this huge impact took place over 4 billion years ago?
Well, you know, it used to be back in the 1860s when George Darwin first thought of this idea of the moon somehow coming from the Earth. It was postulated that could be the Pacific Ocean, that this big, huge basin would be where the moon somehow came from. Now we kind of recognize that the Earth overturns on a period of about 200 million years. The whole surface sort of it convects, and so it'd be kind of like taking a big scoop out of a pot of oatmeal, and you'd see the big divot there for some time, but then it kind of smooths away. Now the search is for more subtle details, like little chemical signatures, maybe at the core mantle boundary of the Earth. Maybe there's pieces of this colliding planet that floated down to the bottom.
Okay, and here's another question. The chemical composition of this object and the chemical composition of the moon and the Earth are pretty much the same. But if this was really a collision by a second alien body the size of Mars, shouldn't there be fragments, chemical composition signatures that are different? But the moon and the Earth seem to be like twins in terms of chemical composition.
Well, you know, chemists don't listen a lot to physicists, and physicists don't listen a lot to chemists, and with some rare exceptions, and that's kind of the bind that we got into around the year 2000 when the physicists were very happy with this giant impact theory for the moon's formation because it got all the details right except for the details of the chemistry, which they didn't regard as important. And the chemists were sort of quietly saying, wait a second, lunar rocks look a lot like Earth rocks. And as that separate field of science went down the trail of looking at more and more details of the lunar rocks, it became abundantly clear that the moon's rocks are almost indistinguishable from Earth's rocks in isotopic composition. That is, the very sort of the details, like what pharmacy did you get your medicine from, or what company did you buy your spices from. Pepper's pepper, but there's different kinds. And so the moon is made kind of the same kind as pepper, so to speak. And that flies in the face of the giant impact models. And so we are actually at this intellectual crisis right now in the moon-forming giant impacts theory, where the simple model that everybody loved doesn't work, but it explains so much. And so we're kind of at a bit of a standstill trying to make progress now.
Oh, so if you want to become famous, come up with a theory that explains why the Earth and the Moon are so chemically identical when they should be different, because there were two different bodies that impacted over 4 billion years ago, right?
Yeah. There's like 5 papers coming out a year almost with different explanations, they range from an impact that was so violent that it just vaporized both the Earth and the Moon, and they reformed as a binary planet. That's an idea that's out there. I think it's a little exotic. Then there's the idea that the impacting planet that collided with the Earth and made the Moon came from right next door to the Earth, and it was formed out of the same stuff as the Earth to begin with. And that's a little exotic as well when you start to look at the details of what that requires. So people are playing these games. Nobody wants to give up on the giant impact theory itself because it works. It's the only theory that really works to explain why the Moon I say it's a lot like the Earth, but it doesn't have a core. It has a very tiny metallic core. It doesn't have an atmosphere, so it doesn't have a lot of water. Why do you make this weird planet? That's extremely well explained by a giant impact. But trying to get the chemistry to do its thing, it's kind of like holding your physicist's feet to the fire. You got to explain why the oxygen isotopes are the same. Otherwise, your theory can't be right.
Okay, well, the title of your book is When the Earth Had Two Moons. So explain to us that the impact was so titanic that it probably created more than just one moon. Explain.
Well, if you came back like a day or two after the giant impact, you'd probably see something that looks like Saturn and its rings. You'd see this massive ring around the Earth, much more times massive than Saturn's rings are. It would be a thick torus, like a donut shape, orbiting the Earth, made mostly of melted rock droplets and rock vapor orbiting the Earth. And that would be unstable gravitationally. It would start to coagulate, kind of like a raindrop coagulates out of a cloud. And you'd start to form bigger lunatesimals, we call them, prior bodies to the Moon. And these lunatesimals would be orbiting, and they would gobble each other up. And next thing you know, you have a big snowball, and then a big mountain, and then a big asteroid. And next thing you know, you've got the Moon, or most of it. And what that does, once you have a moon mass object orbiting the Earth, really close to the Earth, like that was born out of this ring system, now you have this sort of lopsided gravity field. It's not just the Earth, but now you have two bodies, one of them orbiting really close to the other, and that starts to cause other fairly large moonlets to accrete. And these would be at what are called the Trojan points.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today, once again, part 2 with his interview is Professor Eric Aspog, Professor of Planetary Science at Arizona State University, author of a new book called When the Earth Had Two Moons. And so when we look at the night sky, we think things are so serene, so peaceful, so calm. And yet, millions to billions of years ago, that very same spot where you're looking at the night sky was full of debris, asteroids, volcanoes, all sorts of hell broke out in the formation of our solar system. And that's why we have with us a professor of planetary science at Arizona State University talking about these things. Now, I was looking at the astronomical websites a few years ago, and there was an article that underneath Greenland, when we expect to see nothing but rock and ice, there was a crater that seems to have been formed by an asteroid impact 13,000 years ago. Now, I said to myself, now, wait a minute. 13,000 years ago is not 65 million years ago when the dinosaurs were wiped out. This took place when humans, modern humans, were roaming over the surface of the Earth at the end of the Ice Age. And so maybe that impact has something to do with the weather. Well, what's the latest? What's the latest concerning the crater underneath the Hiawatha Glacier in Greenland? A new crater formed 13,000 years ago. What's happening there?
Well, I think, the age dating is not conclusive. It's fairly hard to age date the craters that are deep under the ice sheet when they exactly formed, because really what you're trying to date is maybe melt fragments that might have formed when the impactor struck. It goes back to this hypothesis of the end of the ice ages and this very exotic climate episode called the Younger Dryas, where you had breaching of large glacial melt lakes and fluctuations in climate that were extraordinary and unexplained. And so a number of authors came out in around 12 years ago and postulated that this could have been the result of an impact. And so now, and those, I myself included, who were kind of skeptical, were like arguing that an impact of this magnitude is quite rare, maybe once every million years or so. And so now there's this identification of a relatively large impact structure under the Greenland glacial ice that would sort of fit this hypothesis. It's not a slam dunk yet. It's a very enticing piece of work, but now starts the really detailed stuff: the drilling, the extracting of core materials, the detailed age dating. So I'd say the jury's still out on that one.
But if it's true, does that mean that it could have actually affected the weather when humans walked the Earth at the end of the last glaciation?
Yeah, because a lot of things can happen in an impact of that magnitude. For one thing, you can scatter a bunch of dirt and dust out onto the ice sheets, and you change them from white to black, and that would change the amount of solar heating that the Earth can absorb. And then the other thing, depending on what kind of rocks you hit, if you hit sedimentary rocks versus things like granite and basalt, you could send a bunch of vapor up into the atmosphere that condenses into aerosols. So, for example, the KT impact that wiped out the dinosaurs, one of the big extinction causes wasn't so much the blast and the shock wave and the piles of dust and dirt everywhere. It was that you put a bunch of sulfate aerosols into the atmosphere, kind of like millions of volcanoes erupting at once, and you change the chemistry of the upper atmosphere, and that'll change the climate by 5 or 10 degrees. So these impacts can have a lot of different effects on the climate, largely based on how they kick stuff up into the atmosphere.
And I understand, talking about the crater in the Yucatan of Mexico, a crater that is almost 200 miles across, that dates back to when the dinosaurs died. I understand that relatively recently people are drilling right into the crater and finding actual evidence of the activity that led to the demise of the dinosaurs. Could you elaborate on some of the things that were found? And also, even in the Midwest, they're finding evidence of what may have happened the very day that the impact took place. Could you elaborate?
Yeah, that's really extraordinary because, places like around Denver area, there's actually a lot of outcrops of forests that were buried underneath impact ejecta from this event thousands of miles away down in the Yucatan. In the Yucatan itself, you can't see a crater. The crater's 200 miles across, but it got, after it formed, that was 65 million years ago, then came a period of a lot of sedimentary deposition, basically just muck filling up the bottom of the seafloor, piling it high with sediments until that whole crater was buried. And now, if you're looking for evidence of the crater in the Yucatan, it's actually quite interesting. One of the most extraordinary pieces of evidence that there's a crater there are all these caverns that are formed in the limestone in the Yucatan, forming these cenotes, they call them, these big sinkholes that are full of water. And those kind of line the rim of what the crater used to be. But the crater itself is 3 miles down. So to get to the rocks that the crater formed into, you got to drill through those miles of rock, and then you start to get to the target rocks. And they've started to bring up fragments of these target rocks and try to understand what the stuff was like that it hit. I guess one of the main discoveries that was made early on was the target was really extraordinarily unfortunate to the dinosaurs, because if it had hit like a big pile of granite or a big pile of basalt, it wouldn't have changed the atmosphere so much. But it hit these evaporite beds, this shallow sea that existed at the time, and it pumped a bunch of this sulfate aerosols into the atmosphere and created a whole new kind of a climate regime. And that was really the long haul as that thing played out. And then once you decimated what was on the surface of the Earth and you smothered all these forests, stuff grows back. Plants grow right through all this stuff, and within weeks you started to see new plant life busting through the devastation that was there before.
Now, we understand that paleontologists looking at the fossil evidence now have actually found the fossils, the life forms that died the very day that the asteroid hit. That's remarkable, right? That we're not talking about geologic time periods of plus or minus a million years. We're talking about the very day that the sky fell in. Isn't that amazing?
I think it's extraordinary that you can see these little snapshots in time that just last a couple of days that are 65 million years ago. And that's the power of analytical chemistry, really, is you can look at stuff and do very precise age dating. It reminds me a little bit of looking at the very, very earliest solar system, 4.5 billion years ago, and you can look at these rocks and you can find out that this crystal cooled, 7 hours before that crystal cooled, even though you're looking back at billions of years in time.
And let's say a few things about, could it happen again? We track these things, right? Our military radar systems do track near-Earth objects going around the solar system in the orbit of the planet Earth. But so far, we see no evidence of an asteroid with our name on it, right? What's the latest? And also given the fact that small objects smaller than a football field, we really don't track them. And so it's possible that an object the size of an apartment building could literally catch us totally off guard. What are your thoughts?
Well, things of that size that, we call them city killers, they're like you say, the size of an apartment building. If it was unfortunate enough to explode above a city, that could kill millions of people. They don't make it to the Earth. They're too small to make it through our atmosphere. The atmosphere is actually pretty thick. And so most of these smaller objects, they have it's sort of the equivalent of a nuclear explosion above the city. That's kind of what they would be like. Those were, for the foreseeable future, we're just going to have to live with that hazard, kind of like what happened over Chelyabinsk in Russia.
To Science Fantastic with Professor Michio Kaku. Today we're talking about catastrophic events that have happened in our own solar system. We think that Mother Nature is calm, cool, serene. On a night, you see the huge firmament of stars in the heavens, and you think that things are eternal. Things never change. But then you look at the geologic astronomical data, and then you realize that there have been a number of catastrophes that have shaped our solar system. If you don't believe me, just look at the moon. If you look at the moon, you see these gigantic craters dating back billions of years to the formation of the solar system. So you know that the Earth-Moon system went through a lot of chaotic activity. Well, with us today is Professor Eric Aspog, Professor of Planetary Science at Arizona State University, author of a new book called When the Earth Had Two Moons. Now, speaking about planets, let's say a few things about Mars. The early astronomers, when they looked at Mars, they found dark spots, which we now know to be simply just dark rock. But they also found evidence of a bright spot on Mars called Hellas, which we now know to be a gigantic meteor impact crater. So tell us a little bit about Mars, the fact that it is pockmarked with craters that do not exist on the planet Earth because of erosion, and that's a testament to the fact that Mars went through a period of heavy bombardment. Could you elaborate?
Yeah, we talked about the Earth being like the pot of oatmeal that a big impact sort of scoops out and then it evens itself over pretty quickly. Mars is in between the Earth and the Moon geologically. The Moon is the cold, solid rock at this point and solidified quite early. Mars had geologic activity for, until fairly late in its evolution, but the outer mantle, the outer half of Mars is pretty much a solid rock compared to the Earth, which is a lot warmer. The Earth is bigger, it holds heat in for a longer time. Smaller planets cool off more rapidly and they become harder. And so Mars has these divots that are gigantic compared to anything on the Earth. Hellas is a crater that's about 500 miles diameter. It's about 10 miles deep. It's really this complicated regional terrain because since then, Mars being bigger than the Moon, it has an atmosphere. It may have once had rainfall and snowfall. So you have a lot of erosion that happened in this big, deep basin. But the basin's still there. And any basin that big on the Earth would have been filled in by now. And then Mars has other even bigger pockmarks. The whole northern hemisphere of Mars, we call it Vastitas Borealis, the northern wastelands, the vastness of the north. And it's also this depression that's a couple of kilometers deep and is about a third the diameter of the planet. It's this huge basin in the north. And we're pretty sure that formed in the same kind of a giant impact that made the Moon on the Earth, just scaled down to Mars-sized.
Now, recently, there's been reports of methane gas being found on Mars. It's still rather controversial. Methane is associated with decaying plant material on the planet Earth, as well as natural phenomenon. But it seems to be persistent, comes and goes. But the question is, where did this methane come from, and what does it mean? Any thoughts?
Yeah, that's a big controversy, because if methane is being formed currently on Mars,
welcome back to Science Fantastic with Professor Michio Kaku. Today we're talking about our backyard, our solar system, the fact that it's dynamic, constantly changing, and billions of years ago was the seed of all sorts of catastrophic events as the solar system formed out of rock, gas, and dust billions of years ago. Well, with us today is Professor Eric Aspog. He's Professor of Planetary Science at Arizona State University, and this is part 2 of an interview with him. The book is called When the Earth Had Two Moons. Now, when we think about Mars, we think of a frozen desert. We see no evidence of life on Mars, and yet there's plenty of evidence of previous geological changes. There were perhaps an ocean, rivers, lakes on Mars, but they're all gone. But now we find evidence of methane gas on Mars. Who would have thought methane gas would be found on Mars? Methane gas is found in your kitchen, in natural gas. But why on Mars? Any thoughts?
Well, I'm a proponent of the idea that there's currently life on Mars and that it's deep down beneath the surface. And the reason I think so is that early on, when life was originating on the Earth, about 4 billion years ago, really soon after the planets formed, life started getting a foothold. Material was swapping back and forth between the Earth and Mars. And it seems highly likely to most people who've looked at the problem that mountain-sized chunks of Earth material would end up crashing into Mars, and those would probably have microorganisms on board. So I think the Earth and Mars once shared a biosphere. Now, what would happen to that biosphere on Mars once these lakes dried up and these rivers went away? It would drive itself down below the surface where we have much of the biological activity on the Earth is miles below your feet. 5 miles down, there are bugs. There are microorganisms that live in the absence of any sunlight. They're chemoautotrophs. They live on the energy down in the darkness. And so if those exist on Mars, those might be releasing methane, and that would sort of bubble up to the surface. Now, is that proof that life is down there? No, because you can also form methane by volcanic activity. You can also deliver methane if you had a comet that impacted Mars. That could release some methane. And if you're a super skeptic, and a good friend of mine is an incredibly super skeptic, which is important to have in science, he thinks that these rovers might actually be measuring methane, which is CH4, carbon with 4 little hydrogens glued to it. They might actually be measuring methane that's coming off of the metal, the steel that the rover itself is built out of. And so we have to go through all those little processes to try to see, what the truth is. But from a modeler's point of view, who models impacts and delivery of material from planet to planet, it seems to me like a no-brainer that once there was life on Mars, and that the future for that life would have been to head deep underground.
And so do you subscribe to the theory that if life started on Mars first, because Mars cooled off before the Earth, and a meteor hit Mars and blew some of their DNA into outer space, maybe it landed on the Earth and we are the Martians? Do you subscribe to the theory that we could have been pollinated from Mars? Any thoughts?
Oh, I think that's an extraordinarily good idea. It's like you said, Mars would have cooled off before the Earth did, so life could have gotten going on Mars before it got going on Earth. And it's actually easier to blast stuff from Mars to the Earth than the other way. So just seen from what's the Occam's razor, the simplest idea out there, seems to be that we are Martian. Now, that's conjecture. We don't have the data to prove it, and so that gets to the boundary of what science can really talk about. But I think it's a completely viable hypothesis and even a likely one.
And some people think that our solar system could be like a ping pong game, the ping pongs being meteors ricocheting from Venus to the moon to Mars to the Earth, chock full of activity cross-pollinating each other. Do you think that's a possibility?
Well, you look at Venus. Venus is fascinating because we know so little about it. I mean, it's closer to us than Mars is, but we have had only a fraction of the missions to Venus. It's very difficult to get to the surface because it's a roasting wasteland. But, Venus has a lot of hidden mystery.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest in part 2 of this interview is Dr. Aris Aspog, Professor of Planetary Science at Arizona State University, author of a new book, When the Earth Had Two Moons. Now, leaving Mars, Venus, and going way out there into the realm of the gas giants, Jupiter and Saturn and what have you, there's some controversy as to whether or not there's a new planet out there lurking way beyond Pluto. Now, Pluto was unceremoniously kicked out of the solar system it's not a planet, it's a dwarf planet, but there is possibly a 10th planet, perhaps the size of Neptune, way out there, if you can believe some of the computer simulations of the wobbling of our planets in our solar system. Perhaps this wobbling is due to the fact that there's an unknown planet out there. So what are your thoughts about this mystery planet, the 10th planet? Is there a gigantic planet the size of Neptune way out there beyond Pluto? Any thoughts?
Well, if there is one, we're about to find it because it would be just at the size where routine surveys would start to pick it up. I mean, it's going to be a lot fainter than Pluto is, but these modern surveys ought to be able to start to find an object. Right now, it's a theoretical object, and it's related to Pluto because one of the reasons Pluto was dumped as a planet is that astronomers started to find more Pluto-like planets, Eris, Makemake, these other Kuiper Belt objects that they call them, that are about the size of Pluto. And so you'd either have to call them planets or you'd have to not call any of them planets. Now, it turns out that a lot of these objects, the farther out you look, you start to find these fainter and fainter Pluto-like planets. They all line up kind of on one side of the solar system, so to speak. Their closest approach to the sun is biased to being on one side of the sun. Now, you could say we haven't found them all yet, but if we found most of them, there has to be some cause that would sort of scatter them to having these kind of an orbit. And that's what gave origin to this idea of Planet X, or whatever you want to call it. And calculations showed that it could be about the size of the Earth, up to the size of Neptune, far enough away that we wouldn't have discovered it yet. That's one of those really interesting hypotheses because it's about to be disproven or proven in the next couple of years, because we ought to be discovering it soon.
Okay, and also let me ask you a question about Jupiter. Jupiter is a gigantic planet, the biggest planet in the solar system, and many people believe that, well, it's quite dangerous for a space probe or an asteroid to get close to Jupiter. But isn't Jupiter beneficial in the sense that it helped to clean out the early solar system of debris and asteroids, that in some sense, if Jupiter didn't exist, the Earth could be pockmarked with ancient asteroid collisions, but Jupiter is a vacuum cleaner that helped to clean out the debris of the early solar system. What are your thoughts?
Yeah, Jupiter is a barrier. It's like some people call it the wall to the inner solar system. For anything from the outer solar system, like any comet, especially, to get into the inner solar system, they have to make it past Jupiter, and and past Neptune, and past Saturn. And so it's this game of Frogger, if anybody remembers that old video game. You have to kind of get across, and not get hit by Jupiter. More likely get scattered away by Jupiter, thrown back into the outer solar system. And so Jupiter serves as this kind of protective barricade, sheltering the Earth from a lot of the stuff that would come in from the outside. And then also, early on, Jupiter and Saturn and the giant planets, they were moving around quite a bit. They didn't settle into their present orbits for the first 500 million years or so. And this would have cleaned out a lot of the material in the inner solar system as well. So you could imagine what life would be like on a planetary system that was like ours, except didn't have a Jupiter out there. And you might imagine the kind of extinction event that killed the dinosaurs. You might imagine those things happening every couple of millions of years instead of every 100 million years. It could be quite a different place.
Now, when I was in grade school, we learned that our solar system is very stable with circular orbits and probably very average, that there are probably millions of solar systems just like ours with planets in circular orbits. And I guess, boy, were we wrong. I mean, we now have 4,000 planets cataloged by astronomers, and none of them, hardly any of them, resemble our solar system with circular orbits. And we have wandering Jupiters that wander. Now, how is that possible? Our Jupiter is quite stable. Everything moves in near perfect circles around the sun. How is it possible you can have a gigantic planet like Jupiter that wanders, causing chaos inside their solar system?
So the interesting thing, like you say, we have about 4,000, 4,200 or so confirmed solar systems around other stars, when 20 years ago we had zero. Just we had our system, and the kind of talk about other planetary systems was speculation. Like they're stars just like ours, they should have planets kind of like ours. Of all those solar systems we look at, none of them have the architecture of our system. Very few of them have giant planets far out in the outer reaches. Most of the giant planets that we see would be inside the orbit of Mercury. If you think about it, our solar system is incredibly spread out. compared to most of the systems that are out there that kind of buzz around their stars like a little hive of bees. And so it's a completely different type of a system, and you can come up with specialty theories.
Okay, Eric, unfortunately we have run out of time.